Hi there. I wasn't able to record the session that we had today, but I wanted to make sure a lot of you guys who missed it still had a place to refer back to. Um, the what we are doing today is we're doing separating of fractions, like right here. Problem number one, separating of fractions, where you take a problem and you break it up into two easier fractions to deal with. And the reason why we can do this is we're kind of reversing the common denominator. So when we separate our fractions, if you look at x squared and x squared, those divide out, leaving you just a nice 3 easy integral, which will just leave us to x. And when I try to divide out x by x squared here, x by x squared, we can't do it. So instead what we do is we reduce, and we end up with 1 over x. Now 1 over x is just an identity that we have before, and that's the integral, just a reminder, integral of 1 over x dx is equal to ln of absolute value of x plus c. So a lot of the times when we end up with these dividing problems, we'll end up with this natural log function at the end. If we look at problem number 6 is like this. Or we can divide out instead to make our problems a little easier. Another one that we're looking at is, what if I can't just divide out something easy like problem number 1? If you look at our example number 2, let's go and clean this up. Example number 2. If I can't separate the fraction, another way is just straight use long division. And there's no way for x squared plus 3, there's no way for that to divide into our 4x cubed and 5x squared and 3x and 2. So there's no way for us to separate the fraction. So if we straight divide it, and I'll work with you guys right now doing long division for this problem. The 2x plus 3, and we divide that by 4x cubed plus 5x squared minus 3x plus 2. Long division requires 3 steps. 1, we want to match. 2, we want to multiply. And 3, we're going to subtract. So we want to try to match the front value 2x with 4x cubed. And to make that work, we need a 2. Let me zoom in a little bit. We need a 2, because 2 times 2 is 4, and x times x squared is x cubed. So we multiply that down, multiply to the front and to the back. That gives us 4x cubed plus 6x squared. We said our rules are to match first. So we just matched, we multiplied down, right? We multiplied the front and the back. And our third step is to subtract. We draw parentheses and we draw a minus sign. The way I do it, I make little marks on top to remind myself that's a negative. And that's going 4x cubed minus 4x cubed goes away. And we're left with a negative 1x squared. Okay, you get rid of the 1. Then our next step is to go to match, multiply, and subtract again. We match. We'll bring down the 3x. How do we match? Here's some of these. How do we match the x squared with the 2x with the x squared? Well, we want to get rid of the 2, so we're going to end up dividing. So we need to multiply by a negative 1/2 to make it negative, because we want to match the negative in front. And we're going to multiply by 1/2 to get rid of the 2. And we need another x to make this work. Now take a look at that again. If I multiply the 1/2 x squared times the 2, that gives us a negative 1. X times x is x squared, which gives us our negative x squared we need. So let's go ahead and write that. Negative x squared. Negative x squared. We're going to multiply the 1/2 to the back. right? Using long division, and that's going to be a negative 3 over 2x. And the last step is we're going to subtract. This becomes a plus. Let's write that a little nicer. Let's use a different one. Maybe a plus, and this will be a plus. So negative x squared plus x squared cancels out. And we're left with a 3 over 2, which is 1.5. 1.5 minus 3, we end up with a negative 3 over 2. Remember, this can be changed here to 3 over 2 times 2 over 2 becomes 6 over 2, and 6 over 2, negative 6 over 2, plus 3 over 2 is negative 3 over 2, x. Bring down the last part, plus 2. Now, how can I match, multiply and subtract again? I want a 3 over 2. I want to get rid of a 2. So how can I make 2 look like a 3 over 2? And it's like plastic surgery. You give me what I want a 3, I want to get rid of the 2. And I need to get rid of a negative also. So we're going to multiply this by negative 3 over 2. Oops. I need to make this into a 4, don't I? I need to make this into a 2. So 2 wouldn't be enough. We actually need a 4. Because 2 and 4 cancel out to become a 2, right? And this was already a... want that to be negative. Okay, so we're multiplying by negative 3 over 4. So negative 3 over 4. We multiply down. We match, now we're multiplying down. We end up with negative 3 over 4 times 2 is negative 3 over 2x, which is exactly what we wanted. The 3 times the 3 becomes a negative 9 over 4. And then we match, we multiply, now we're going to subtract. And we end up, we need a common denominator, we need a 4 here. So if we give it a 4 over 4, that gives me a 8 over 4. And then we're going to distribute the negative. That becomes a plus. It's a plus and a plus. And 8 plus 9 is the 17 over 4 that we need. To rewrite this at the end, we end up with a plus 17 over 4 divided by 2x plus 3. And that's the answer that they got here. So now once we do that, we can take the integral of all 4 terms, all 1, 2, 3, all 4 terms separately. The first one, 2x squared, is a power rule, so 3 over 3. That's our answer over here. Our 1/2 x squared will be x2 over 2. Squared over 2 times 2 is 4. Our next one is a constant, minus 3 over 4 becomes a 3 over 4x. And the next one is 17 over 4. Looks pretty terribly hard, but how did they end up with such a nice ln number? We'll do it on the side here, just to show you guys. What is the integral, the integral of 17 over 4 over 2x plus 3 dx. Now this looks actually quite hard. It looks like it's kind of confusing. A fraction and a fraction. Well, let's rewrite this. Would you agree with me that 17 over 4 is a constant? We can always kick out the constant. So that's just 17 over 4 in the front. Integral of 1 over 2x plus 3. If you joined us in the live stream, I mentioned that these integrals are pretty easy now if we use U sub. this is going to translate to an integral of 1 over u du with some extra stuff on the outside, right? So u is equal to 2x plus 3. The derivative, automatically just take the derivative as 2 dx. So we need to bring over a du over 2, 17 over 4 integral of 1 over u du over 2. This 2 gets kicked out, and that's how we end up with a 17 over 8 on the outside. And then the integral of ln of u, I'm sorry, I just did the integral in my head. Integral of 1 over u du is 17 over 8. I'm sorry, I should write this a little nicer. 17 over 8 natural log u plus c, where u, we can plug it back as 2x plus 3. And if we take a look, that's what they put here. Yeah. We did run through a couple of these questions. Most of these are actually u substitution, and I emphasized in the live stream about identifying which problems would be u sub. And I'm just going to quickly go through that right now. So let's actually quickly do a refresher of what I just went through. I'm sorry. First, if we end up with, usually it's some type of polynomial on top and some type of easy power on the bottom, we can oftentimes split that into two different fractions. Now, what we always want to try first is u substitution, and we talked about during the stream that you can identify u substitution problems quickly by picking a sacrifice. If I choose x squared to be a sacrifice, the derivative of x squared is 2x. And does 2x get rid of the stuff on top? Nope, not a u substitution problem. Does the derivative of 2x plus 3 get rid of this on top? Nope, not a u substitution problem. If we look at how to identify when we can we use a u substitution problem? If we look at, let's take number 12. If I choose sine to be my u, derivative of sine is cosine, that's going to get rid of this cosine on the side. If I choose over here, the more complicated one, derivative of sine 2x is cosine 2x. That's going to u sub. Of course, there's some constants to be brought over. If I look over here, number 13, cosine, derivative of cosine is sine, 3x times 3. The sine's going to get rid of this sign over here. Problems like this over here. Number 11, do we know what the integral of cosine is? We do. Integral of cosine is sine, and that 2x is what we're going to u sub in this place. So u will be 2 over 3x. du is 2 over 3 dx. dx, we always solve for dx in the end. du 3 over 2, because we're multiplying the 3 dividing the 2. So that's what we're going to bring back. This is u substitution. Number 9 is a trick question. This is a question that either you spend a lot of time doing or you've seen it done. The integral of tangent 2x minus 7 dx is always broken up into, because we don't have any integral for tangent, we don't memorize that, unless if you've done it a lot of times and you memorize how to do this. We just break it up to the sine cosine. And now it becomes a u substitution problem, where what's the derivative of cosine? That's going to be negative sine, and that's going to get rid of the sine on top. Turns out it's a u substitution problem. This one over here, that's number 8. That's also a u substitution problem. Number 15, that's like tangent, where we break it up into cosine over sine. Cosine over sine, and that's going to be u substitution problem. But problems like 16 and 17, we talked about it before. There's no way for me to do u sub on 16 and 17. The derivative of x squared is 2x, that doesn't get rid of the top. 17th derivative of x plus 2 is just 1, and that doesn't get rid of the top. So can we split this into separate fractions? Separate fractions only works nicely when it's just a simple value. So it's going to be our long division. So practice it with those long division problems. Let's see. Separating fractions. So if we're separating fractions like example 1, that's going to be 3 and 6. Number 5, would that be u sub? The derivative of 2x squared plus 1. The x's cancel out. That's great. This one here, that was not going to be u sub, right? And we can't separate the fractions. So instead, we have to use long division on this one. Okay, hopefully that was helpful. If you have any questions specific on this, please let me know.